right there.
Right.
And then we have GK perpendicular to KJ. There, right. So it looks like that right there. So
Okay.
those are given. What else do we got here? We got that, well, we're going to be able to show that this angle is congruent to this angle. Those are vertical angles. But we're missing something else to be able to do this problem here. So there's when you're proving triangles, you have a couple of possibilities: side, 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 angle, side, angle, side, angle, and then angle, angle, side.
Right. Yes.
So what I'm seeing so far is we definitely have two angles that we're going to be able to use.
Mhm.
So we're either ASA or AAS. It would be really nice if we could prove that MH is congruent to HK. That would be really nice. Otherwise, we've got to prove that there's another side, namely GH is congruent to HJ. And I'm not seeing anything in here that will allow us to do that. Let me just look one more time at these. JM, GM, GK, KJ. Okay. What are you seeing? Are you seeing anything here? Because I'm
Um, no, I don't see something.
which chapter or section or page number are you on? Because I think I've got a copy of this book that I can pull up here.
This is 7.22 proof oriented triangle theorems.
7.2. Okay. So this is the geometry for enjoyment and challenge. This is the challenge part. It's not supposed to be though. It's problem set A. You said 7.2, right? Yes. Okay, there it is. Okay. Oh, okay. I'm sorry. Yes, that's why it helps here. So these are right triangles. Sorry. So these do not apply. Well, they do, but they for right triangles, it's much simpler. For right triangles, which I didn't even recognize, I should have recognized that immediately. There are much simpler proofs for right triangles. You just need an angle for that, because the other angle is automatically congruent to the other angle. And we'll show that here. I guess that's called the no choice theorem. Does that sound?
Yeah, we did that today.
Yeah. Okay. Which I don't really like the naming of, but that's what it is here. So what I like to do, and that's what I was trying to do with this drawing, is I was trying to sort of mark it up in a way where it's like, okay, now we kind of know what we're doing to be able to answer this proof. So statement and reason here. Our first statement is the first given, JM perpendicular to GM. And then let's say what that leads to. So that leads to leads to G angle GMH is a right angle. Is that okay? Is that clear?
Yes.
Okay. Now this is the harder part, is like, well, why is that true? And it's just typically like definition of perpendicular line segments. And that's essentially what JM and GM are. They're just perpendicular line segments.
Right.
Now you have to go on and say the measure of angle GMH equals 90 degrees. And that's the definition of a measure of a right angle. This might be an extra step. I'm not sure.
Yeah, I don't think my teacher would require
Okay, good. So we've shown that this is a right angle. we need to do the same thing with the other given to show that this is a right angle. So it's the same first two steps. Let me cross out this one here. It's the same first two steps, but you just use the other letters here. So you would say GK, this is 3 now, GK perpendicular to KJ. That's also given. You could put it up in the first given, that doesn't matter. And then angle, let me see, do it the right way. So JKH is a right angle. And that's from the same reason, definition of perpendicular line segments.
Okay.
Okay, so like one of the nice things I can do, I know you can't do this, but I can almost sort of reset here and say, all right, well, what have we actually proven here in this picture? This is critical because it's like, all right, all we've proven is that angle and that angle are the same.
Right.
Okay, we need to, so we know that it's a right triangle, but we're going to do a bit more. We need to show that that angle and the order matters here. So I'm going to go MHG is congruent to angle KHJ. So that means that these two angles are congruent here. And the reason is vertical angles are congruent.
Okay.
Okay, so now we have 2 of the 3 angles are congruent. So for 6, we can say that, and this is the one time we can probably use a single letter, angle G is congruent to angle J. And this is the no choice theorem. And the reason that works is we've already proven that the other 2 angles are congruent, therefore the third angle must also be congruent.
Okay.
Any questions on that?
No, thank you.
So that allows us to prove that the triangles are congruent. And again, the order matters here. So like you've noticed, I've been starting at the 90-degree angle, going to the vertex. You have to continue that. So it's MHG congruent to triangle KHJ. Oh, I'm sorry. I'm sorry. We don't need to prove they're congruent. We've proven the conclusion. I apologize. We've already got it.
Okay.
Yeah, they're going a little too far. Got to know when to stop. Okay. Any questions from that?
No, thank you.
Okay. All right. So number 2, and we know that the problems today are usually the easier ones of the 2. But we'll see where we go. So now just since we haven't worked much here until now, whenever I see a picture like this, I know that many times it's a good idea to separate the two triangles. And this happens again in trigonometry as well. Okay, now I'm not saying we're going to need it, but it's sometimes good to separate them to like visualize certain things. So let's keep going here. All right, so it says our goal is to find the measure of angle A, angle C, and CED. Okay, let's see what we got there. So CB is perpendicular to AB, so that means that's a 90-degree angle. That's the first given.
Okay.
And then DE is parallel to AB, so that gives us that this angle up here is also 90 degrees. And the reason is corresponding angles. That's from earlier in the course. Now they tell you that CDE is 40 degrees right here. And also by corresponding angles, this is 40 degrees down here. This is also going to be corresponding.
Okay.
Okay, now this is a good time for us to go to that bigger triangle here. So we've shown that angle B is 90, angle E is 90, and that's 40 and that's 40. So by the no choice theorem, but also just by sort of inspection, the missing angle in both is 50 degrees. The no choice meaning the third angle must be the same if the other two angles are the same.
Okay.
Is that okay, or would you like an analogy or something, some other like description of that no choice theorem?
No, that makes sense.
Okay, so we've essentially done the proof without writing it down. Now we got to be very, very formal and write down all the steps.
Right.
Is this at all how it's presented to you in class?
Yes.
Oh, that's good. Okay. So the first thing here is to write the given. Now, do you like to write all the givens or do you like to use them as you need them?
I write them all at once.
Okay, so we can do that here. DE parallel to AB, and then angle CDE equals 40 degrees. Should say the measure of angle. Anyway. Okay, so those are all given. So you really want to start with one given at a time. So using the first given, what does that mean? What does that tell you? It tells you that it tells you that angle B is 90 degrees. So we can just say that angle B is a right angle. I'm sorry, we need to say it is a right angle first. And that's the definition of perpendicular line segments.
Okay.
So it's almost always, you almost always write the word definition of whatever it is that you're being told to use. And then I like to denote that I've used it or somehow indicate, hey, I've taken care of that. Okay. So from angle B is a right angle, then we move to angle E being a right angle. Okay. And we need to say that we can just say that angle B is congruent to angle E. And the reason is that they are corresponding angles. Corresponding angles are congruent.
Okay.
And that's enough. I mean, that's enough to say. So then, then you can say, yeah, I mean, I think that's sufficient. I don't think you need to actually say that the angle E is a right angle. What do you think?
No, I don't think so.
Okay, and I'm trying to gauge what you think from what you know in class. So since the measure of angle CDE is 40, we now know that the measure of angle A is also 40. So we can say the same thing. Again, this is one of those like where I don't know if you have to be that specific. Like one way of doing it is to say the angle CDE is congruent to angle A, and that's from corresponding angles again are congruent. But then there's the next one, which is the measure of angle A, like where you actually give its measure. Its measure is now 40 degrees. And you do that by saying that congruent angles have the same measure.
Angle C and angle A.
No, angle A. Angle A is this one down here. So CDE is this one kind of inside the smaller triangle. It's congruent to the angle down here, angle A. And
Okay.
the reason they're congruent is because they're corresponding angles.
Right.
But sometimes you literally have to like go a little bit further and say, oh, they're congruent. Well, what's their measure? Well, their measure is the same angle measure.
Right. Thank you.
And it's the same thing I was trying to ask you about in the previous problem with the measure of a right angle, whether you have to actually explicitly state whether it's 90 degrees. again, like I don't make these rules. I don't care. I mean, I don't think proofs are very useful, but you have to take them. You have to take this class. So that's why we're trying to figure this out here. Because it does ask for the measure of angle A. That's why I did that for you. So, and we kind of should have snuck in like a measure of angle CED. So CED, sorry, CED is this other one. Like we just say it's a right angle. We never actually give its angle measure. So what we could do is sneak that in right here, 3.5. Well, it's easier for me to do this than for you. We can just sneak that in here and say that the measure of angle CED, and that's really angle E.
Mhm.
You say that congruent angles have the same angle measure.
Right. Okay.
All right, so now where we're left with is that we've proven, and again, sometimes like I know this is easy for me to do, but it will help your learning here if I just insert this figure again. So we've proven that B is 90 degrees, E is also 90 degrees, this is 40 degrees, and this is 40 degrees. So what is left is to say that measure of angle C is 50 degrees. Okay,
Right.
now how do we do that? Well, we actually have to be a little bit, we have to like work our way towards that. We have to say the measure of angle C plus the measure of angle D plus the measure of angle E has to equal 180 degrees.
Okay.
We can't just say that it's 50 degrees. We have to like have some justification for it. And we know that the sum of the interior angles in a triangle add up to 180.
Right. Okay.
So then you can substitute in for the known angles. You can substitute in for the known angles. And that's just substitution. There's no, when it's an algebra step, you don't really need much justification. Just say, substitute, I'm done.
Right.
But now from here, this is where you, I'm okay if you just say it's 50 degrees and you say subtraction property of equality. Because you are literally subtracting 40 from both sides of the equation and subtracting 90 from both sides of the equation. So on the right-hand side, and this took me a long time to figure out as a student, is you're just giving like the words that describe the step that you're doing. And it's not any more complicated than that. If you're subtracting from both sides, you just say subtraction property. If you're dividing, it's property of division.
Okay. Got it.
Okay, so I guess we can move on to number 4.
Okay.
All right, so there's a lot of givens in this problem. It's also there's also a lot of triangles. That's potentially problematic here. So we'll see what we need to do here in terms of like breaking this apart into different triangles. So it says MR is perpendicular to KP. MR, KP. So that means that's a right angle. It also means that's a right angle if we care. And then similarly, KO is perpendicular to PM. So that means that's a right angle and that's a right angle there.
Okay.
So like I'm going to do this here just for this particular problem, but like that's RKM is a right triangle. And then you've got the other one up here. RPM, that's also a right triangle. And then you've got it going the other way too. And I hope this has been shown in class before, because it's terribly confusing to have all these lines overlapping.
Yeah, he highlights them. He doesn't really split them up though.
Yeah, I like splitting them up. Highlighting could be, depends if you're a visual color person. If you're more spatial, you like seeing them separated.
Yeah.
So now it says angle RKM, which is, see, that's the problem. It's like, well, it's that one, whatever that is. So it's really that one
Mhm.
is congruent to angle OMK, which is really that one, or it's this one down here, but it's like that one there.
Okay.
Any questions on that so far?
No, I've got it.
Okay, so our goal, and this is probably a good place to highlight, our goal is to prove that triangle RKM, which actually it is good that I've this triangle right here is congruent to triangle OMK.
Okay.
Okay, so the couple things that I notice here, and I hope you're seeing in these triangles that are in yellow now, do we have enough to prove that the other angles are congruent? Is this angle congruent to this angle?
Yes.
What is the reasoning for that? What that we've been talking about for a couple problems now?
The no choice theorem.
No choice. Yeah, there's no choice. It must be that. So if that is the case, well, we can prove that the angles are the same, but is that enough to prove triangles are congruent? No, because, sorry about that. The triangles, you're limited to, I always like writing these down, side, 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 angle, side, angle, side, angle, 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 side. So none of those apply here, but because you have angles congruent, you're generally looking at the last couple here, and actually more specifically the last two.
Okay.
So what do you notice about this bottom piece right here? Bottom side in the two triangles I've drawn.
They're like the angles.
Side, looking at the side, just the
Oh.
side.
It's like that is just straight.
Okay, but in terms of the triangles, what do you see in the triangles? At the bottom there, the base. I'm trying not to just tell you, because if I tell you, maybe it won't be as clear, but tell me the line segment that's the bottom of this triangle over here on the left.
KM.
Okay, and how about the one on the right?
KM.
Did you give me the same letters?
Oh, that they're congruent.
Yes. Why are they congruent though?
Because they have
Like,
the same.
so when you look at yourself in the mirror, why is it the same image?
It's reflected.
Yes. So this is called the reflexive property. The reflexive property shows that those two sides are congruent. Now, why is that important? Well, angle side angle requires you to have a side between two angles. Do you have a side now between two angles?
Yes.
You do. So that's the one we're going to use.
Okay.
So this is what's hard for teachers to grade. Like, we've just done the proof. The proof is done. Now you got to put it down in steps, but if you've got to try to go through this like sequencing. It's almost like a game. It's like, all right, if I get this piece and I move to this thing and I do that, and then I get that and I'm done. You have to be able to like persevere through these things. And it's not easy at all.
Yeah.
Okay, so you ready to write this proof up?
Yes.
Okay, so the first step is to write all the givens. MR perpendicular to KP, KO perpendicular to PM, angle RKM is congruent to angle OMK. And those are all given. So the second step here is to use the givens to show that the angles are 90 degrees or right, they're right angles. So our second line here is that angle KRM, comma, angle MOR are 90-degree angles, or right, I'm sorry, right angles. We can't say that yet. And the reason comes from the given. So we use these two givens. What would the reason be for that?
Because perpendicular lines.
So definition. It's always got to do something like definition of perpendicular segments.
Okay.
Is that okay?
Yes.
Okay. So for number 3, now we move to, we probably want to say that the angles are congruent. We want to say that angle KRM is congruent to angle MOR. And the reason is that angles, all right angles are congruent, I guess you could say. That's probably okay.
Right.
So that's like thing 1. We've got angle. We need to get the other angle. We'll get the side here in a moment. So the other given is that the angles are congruent. So now we really have 2 angles that are congruent in the right triangle. So now we can say that the other angle, the non-given angle, is congruent. I think we did that in blue. So we can say that the blue ones here, that's the no choice.
Right.
Okay, so we'll write those down next. We already know our reason, no choice theorem. So the order kind of matters here. Let me do it this way. Angle KMR is congruent to angle MKO. And that's the no choice theorem. So that gets you back to those 2 triangles on the right where the angles are congruent.
Right.
So the last step is to prove the side in between is congruent. So you got it, and you do have to switch the order. It's like KM is congruent to MK, and that's the reflexive property.
Okay. Got it.
Okay, so we're basically there. The triangles are now congruent. We can prove the triangle RKM is congruent to triangle OMK by the side, angle, side. Sorry, no, angle, side, angle. Sorry, used the wrong one. Angle, side, angle postulate.
Okay. Got it.
So these are the type of problems where I would recommend going back later on and watching the video, pausing it, seeing if you can do it on your own. Fresh sheet of paper out. There's really not like a similar problem I can give you to be able to do like this. You just have to try working it out fresh, and hopefully some of the things stick for the new problems that you're going to do.
Okay.
All right, so number 8 is not a proof, is that right? It's just sort of a solve problem.
Yeah.
Great. So it says the measures of the angles in a triangle are in the ratio 3, 4, 8. So with ratios, you can always add an x like this, 3x, 4x, and 8x. And that helps you with the angle measure. 3x degrees, 4x degrees, 8x degrees. Okay, so now we need to first determine the value of x. So what do the 3 angles in a triangle add up to?
180.
180. So you can write 3x plus 4x plus 8x equals 180. And you can solve for x. So 15x equals 180. X equals 12. But that is not your answer.
Right.
That's just the value of x. Let's go back and see what it actually wants here. It wants the measure of the supplement of the largest angle. So we ought to at least put that value back in triangle. So it's 3 times 12, that's 36 degrees. 4 times 12 is 48 degrees. 8 times 12 is 96 degrees. So something like that. Now I'm gonna just move this down so that I can make some more lines on this. But the supplement, for example, the supplement of the angle on the right here is drawing out, and you can go either way. You can go that way. It doesn't really matter, but because you're going to get the same angle, but you want to get the one angle that's on the outside. So that the supplement means they add up to 180.
Right.
So this would be like 84 degrees.
Okay.
So we got to find the 3 supplements here. So it's 144 degrees, 132 degrees,
Okay.
and we're looking for the one, if we go back to the question, the largest angle, so the largest supplement. So it looks like it's 144 degrees.
Okay.
If it asks for the smallest, it would be the 84 degrees. So it's a good question because you can't just solve for x. You have to do something with it.
Right.
Does your school still do the like algebra blasts?
Algebra blast?
Yeah, I think so. Okay, I remember that was kind of common a few years ago. They give you some sort of algebra thing like these types of problems to solve. Okay, let's move on to number 9. Or 9 here. Is this the usual amount of homework you get, or is this light? Or
Today he gave us 2 assignments, but he gave us time to work on the first one in class.
oh, good. All right, so we got given triangle as marked, find the measure of angle 1. So there's a couple of ways to do this. The measure of angle 1 plus this other one over here, 4x minus 10. That's its supplement. They add up to 180 degrees. And that's using a supplement or a linear pair. Okay, but the problem with this is there's like 2 variables. It's like measure of angle 1, whatever that is, and then x, which we don't know. So we can't do that. Like that's not going to work. The next thing we know is that all the angles in a triangle, they add up to 180.
Right.
Okay, so you're like, all right, well, but the problem with that is, again, there's 2 variables. There's, measure of angle 1, like consider, like if you want to think of that as y, You got two variables. Now this is a system, so you could solve it using using a system. Okay, but there's in fact a better way. Have you
Oh,
heard of the exterior angle theorem?
yes.
So it says the exterior angle, or the supplement, is equal to the sum of the other two angles.
Right.
So that's the shortcut here. That's sort of say, okay, that 4x minus 10 on the outside, that equals the 50 plus the 2x. I think that's a plus 10 there.
Yeah.
Now, if you had tried to solve the system, you would have gotten to the same place. Okay, so do you want to try solving this one on your own and see what you come up with for x?
Sure. Um, 35.
X equals 35. How confident are you in your answer?
Pretty confident.
Pretty confident. Okay. Now, is that what they want? Is that what they're asking for? No, they're asking for the measure of angle 1. So you still have more work to do. So you in fact almost have to go back and find these other angles to answer that question. I guess I would find this one over here, the 4x minus 10.
Mhm.
4 times 35 minus 10 is 130. And then to find y, I would subtract from 180, because the y plus this other one, since they're the supplement, they have to add up to 180. So y is going to equal 180 minus 130, which is 50 degrees.
Yep. Got it.
Okay, now you said you had another assignment. Did you get done with everything in that assignment?
I did.
Okay, do you have some other things that we can look at today?
Um,
Got about 10 minutes left here.
no, I think that's all I have.
All right. Well, it's up to you. We can stop here or we can keep going if you got some more stuff for us to look at.
I'm good, thank you.
Okay. All right. Well, I guess we're going to get on a regular schedule starting after Thanksgiving. So I appreciate you letting me help you today. Hope you enjoy your time off, and I'll see you a week from now.
Thank you, you too.
Okay. Bye now.
Bye.